Good morning, viewer. Bienvenue. Here's a breaking news and most amazing too. Yeah, as global temperatures increases, the demand for sustainable cooling solution is also on the rise. A team of researchers from UCLA and their collaborators have developed a cost-effective and scalable method to cool buildings during the summer and heat them in the winter. Led by Aswath Raman, an associate professor of material science and engineering at the UCLA Samoli School of Engineering, the research team recently published a study in Cell Reports Physical Science detailing a new method to manipulate the movement of radiant heat through common building materials to optimize thermal management. Radiant heat, which is felt whenever a hot surface warms our bodies and homes and is created by electromagnetic waves, travels across the entire broadband spectrum at ground level between buildings and their environments, such as streets and neighboring structures. On the other hand, heat moves between buildings and the sky in a much narrower portion of the infrared spectrum known as the atmospheric transmission window. The difference in how radiant heat travels between buildings and the sky versus the ground has long presented a challenge to cooling buildings with less skyward facing surfaces. These buildings have been hard to cool in the summer as they retain heat from the ground and neighboring walls when the outside temperature is too high. They are equally difficult to warm in winter time as the outdoor temperatures drops and the building lost heat. If you look at historical cities like Santorini in Greece or Jodhpur in India, we find that cooling buildings by making roofs and walls reflect sunlight has been practiced for centuries, said Raman, who leads the Raman lab at UCLA Samoli. In recent years, there has been massive interest in cool roof coatings that reflect sunlight, but cooling walls and windows is a much more subtle and complex challenge. However, with the proven success of cooling buildings by using super white paint on the roofs to reflect sunlight and radiate heat into the sky, the researchers set out to create a similar passive radiative cooling effect by coating walls and windows with materials that can better manage heat movement between buildings and their surroundings at ground level. The researchers demonstrated that materials capable of preferentially absorbing and emitting radiant heat within the atmospheric window could stay cooler than conventional building materials in the summer and warmer than they could during the winter. We are particularly excited when we found that materials like polypropylene, which we sourced from household plastics, can selectively radiate or absorb heat in the atmospheric window very effectively, Raman said. These materials broader on the mundane, but the same scalability that makes them common also means that we could see them thermoregulating buildings in the near future. Beyond this exclusive report.